I'm going to be beginning on AI today. I think I've got the player to a point where I'm happy with it, or at least happy enough, given that I need to move on and work on AI. So I'm going to be starting on AI, and I've made kind of a flow of what I want to do. Primarily, the way I need to think about the AI is how they can adapt to um, understanding behaviors without needing the context of those behaviors. So the way I'm thinking about AI is that I don't want Um, so let's say we have four bosses. I don't want it to be the case that each boss needs particular code to understand the player specifically um, alongside their personal kit of moves. So let's say the Mole King can dig down as a way to avoid an attack. Um, then if I'm going a traditional route of programming AI, I would have custom code for the Mole King, which says when he should and should not dig, based on the player's actions and how the Mole King should respond to those player actions. So it would be this code that is entirely reliant on contextual situations, which have to be hard coded rather than something more adaptable. So my goal here is to create an adaptable system where an AI can be given any range of abilities to use. So it could add abilities and take away abilities without that affecting the AI's ability to make decisions. The way this is going to work is that the AI will have a list of actions it can commit along with basic movement actions. The movement it'll be able to do will be derived from its movement script. So let's say, for example, there's a boss that cannot move at all and it doesn't have a movement script, then the boss won't see that as an option. Then, aside from that, what we will do is give the boss a list of actions based on the animations it has available in terms of automating it. So we will instantiate a list of calls because every single action in the game is essentially just a call to the animator to change a call to the action state to change the action state, which then changes the animation. So if I give a boss four animations that do four different attacks, then it will be listed in an array. This is what I'm thinking I'll do. It'll be listed in an array where we've assigned what the name of that animation is and then tying the action as well to that. So if it's got four attacks, it has four options: slot 0, slot 1, slot 2, slot 3. Now, each of these will have parameters within their actions because what I want to create is modular actions which describe what the action will do and then has code attached to it for context independent actions. So right now, the way I've done the player code is that it is contextual. It's written within the player code itself, and it's not something any other object could use. I want to create modular actions for the purpose of allowing an AI to read any action. So what that'll involve is taking the player code that we have and then abstracting that into a script that doesn't rely on anything contextual. And so let's say, for example, the player's jump. What I need to do is take that from being the player's jump and turn it into a jump. That's what I have to do for every action. And then once we do that, we can assign parameters to every action that describe what that action will do, how it gets its targets, and the severity of the action. So let's say a movement action, that's going to have no downsides to the AI. So it evaluates that differently than an attack, which does damage to the AI. Then it can also see the targeting of the attack. So let's say the player is about to attack. The AI can see, is this going to hit us? Is it not? Now, the way this will work is that every single action will work that way, and it is not dependent on what object it is attached to. So if a barrel is going to explode, the AI can read that barrel's action of explode and see whether or not it'll hit it the moment the explosion begins. Okay, so I think that's a good explanation of what we need to set up, and I want to go over this flow to explain what happens. So I went over a bit this here, so let me just draw over this. So I went over a bit how the call to action works. You call an action which begins an animation. Obviously, we check that there's an actual action attached to that animation. So for example, we only do an action attached to the forecast of an entire animation, even though even though an action is made up of forecast, action, post action. Now within that, we can have stuff that says wait until the action begins, wait until the post action begins, but it's all based on one state, the forecast. I do that just for keeping it more orderly than having the action split up across 3 different animations. Now, after that goes, we begin firing the action, which is going to be the modular action I was talking about. Now, this is going to have all sorts of parameters and then as well as code to actually fire, which will do the effect of that action. But the moment it begins, the exact frame it begins, the AI will have a list of objects that it is paying attention to. So we could see this as like a sight layer, which is just a bunch of objects that it can see. So this could be a barrel, it could be the player, it could be another AI, it could be anything. Now it is going to be tracking when an AI is beginning a new action. So when any other object is beginning an action. So when it sees that something is beginning an action, it will start processing what it should do about it. So first thing it'll decide is, based on the parameters of this action, should we avoid it or should we go to it? So that's the first thing, figuring out what our action should be. So do we want to avoid it? Do we want to go to it? The next thing we do is figure out, will it hit us at the current moment? So let's say we want to avoid it and we check, can we hit it? And the way we're going to do that is we're going to reach into the action and take its exact same methodology for finding targets and just pull that and use it. Now it's going to be a bit different because we're going to have to be jumping forward in time. So let's say, for example, the player is going to do an attack that fires in 1 second and it's going to be grabbing targets. Well, the AI is going to be predicting what the player will do. So what we'll do is we'll take the player's current velocity and we're going to make a guess of where it's going to be grabbing those targets and maybe overshoot it a bit. So we use that to make a rough guess of where this player is going to be hitting. Well, I say player, it can be any object. We're going to get a rough guess of what is going to be hitting and where it'll be hitting. And then figuring out, do we need to move towards that? Well, here we figured out, do we need to move towards that, away from that? If we're already outside and we're avoiding it, then we don't need to go towards it. If we're inside and we're avoiding it, we need to leave. And then we can also decide after that. So now we know, is it going to hit us? Is it not? We know, do we want to be hit by it? Do we not? Or do we not really care either? That's another thing. Like, are we benevolent to whatever this is? And then the third action is, what do we do? What do we do with this information that we now have? So we have the information of what benefit does this ability have to us, and is it going to hit us? So we know those 2 things, and with that we can decide how our action is going to be. So maybe we want to stop this action before it begins, so we can see, has this action started? No. Do we have an action that'll fire faster and do damage to the target so that it does not perform this action? So first thing we need to know, is this an action that can even be stopped? So let's say a barrel exploding. If a barrel is exploding, that is not an action can be stopped. So it would be ridiculous for our AI to say, okay, we're going to try to interrupt this. So that's not an option. So we would check, like, is this action interruptible? Do we have time to interrupt it? Should we move away? Should we move towards it? Should we take the hit of what it's doing? And is it better to do damage to it? So that'll kind of come down to weighing out, like, does this thing have health? Would it be a better exchange if I hit it than if I didn't hit it? So we decide what action we are going to take. And the way we do that is we look to the list of our actions. So we have like our actions here, 1, 2, 3, 4, just, actions going down. And we look to those and we see, okay, which one of these is offensive? If it's offensive, it'll interrupt the target. So do we want to use one of those? Do we want to use one of our movements to get away? Or do we want to do some other ability that'll make us negate the damage? So something that'll make us dodge. So we make our decision. Then the final thing we do is we're going to remember what we just did. So what we're going to do is we're going to take that action just fired, give an ID to it. So we're going to give an ID to the action. And then we're going to store that. Attached to it is going to be our response. So we're going to also have the ID of our response. And then we're going to have a value which says like was this successful or was it not? So it'll be a point-based thing that says, are we better off than we were when this exchange happened, or are we worse off? Is the target that we just reacted to, is it better off or worse off? and that'll equate to a score. And then we can attach that to the score to decide next time. So let's say this ID, we have this ID of the action, and it comes through again, same parameters and everything, goes to this ID. We see this is the reaction we did last time. We can consult that score, see if that's like a good score or a bad score. If it's a good score, we can run this reaction again. And then we could also have something like, okay, we've done this 3 times, now let's switch it up and do something else. Or as we're running this reaction again, we calculate the score again. And so let's say the first time it comes through and we get like a score of 3, which for this example is a good thing. So we get a score of 3 and we say, okay, we want to do this again for the reaction. It's the same action coming through, we're giving the same reaction, let's do this, but let's also recalculate what the outcome is. So let's try to remember this again. Now, for whatever reason, this time we get a score of -3 and we realize, okay, that didn't work this time. So next time we come through, it's going to say, okay, this reaction got a score of -3. Let's redo our calculations, try something else, and see what score we get from that. So maybe we do something else, we do a different action, and then that branches off, and we get a new ID, and this one gets a score of +2. And we say, okay, that's better than -3. We now have two reactions for this parent action. And now we can say between these two, we want to do this one, and then we'll recalculate that again, and then this gets -4. And we go, okay, what if we go back here, or what if we try another one? And I think you get the idea of what we're doing here so that the AI has a memory and it can make better decisions as the fight continues. Now, with this, there's a temptation for me to do machine learning, because what we could do is easily transfer this into a machine learning algorithm that can then be run again and again and again as we try to train the AI to be smart with any encounter. I might do that, but I most likely won't, because it'll take a lot of work to do, and I'm not sure it'll be worth it in the long run. So I think this is a decent start, and we can just have the AI remember it in this instance and create a rudimentary machine learning system. So yeah, that's the goal. That's what I need to be starting on. So I think the first thing I'll do is I'll mock up an AI to track targets. And then from there, we will see how we can set up the AI to read an action. Once we have it that we can read an action, so essentially recognizing, the first thing we want to do is recognize when this call happens. So this is goal number 1. We're going to recognize when this happens. Well, really when this passes as true. So when the action actually performs, we're going to want to document that. So the very first thing I'm going to test is just kind of debug log, sending this to the AI that we've recognized that something we are tracking is performing an action. So that's step 1. After that, we're going to begin setting up all of this, because we need to still create the modular actions so that the AI, so that we have modular actions that can be read based on their parameters. I have a rough draft of what this looks like, but it needs more work than it has currently. So those are the 2 major goals. Get the AI to recognize, well, build the AI in the first place, get it to recognize this procedure happening, and then start working on the actions themselves. Okay, I'm going to get started on it, and I will be on mute until I have something to show. I think I'll take a moment real quick to kind of explain what I've been doing for the past 20 minutes or so. I've been working on creating an building script, an initializing script for the player input and AI input. For the player input, up until now, I had been kind of sloppily initializing the script by putting it on the testing script, which is specifically for just testing functionality, which obviously the player input script should not be initialized on a testing script, because this will be, the testing script will be deleted by the time the game's actually done, because it's purely for in-editor testing. But I just thrown it on there as an easy way to initialize the script while I was testing it, because again, these are still work in progress scripts where I'm kind of just figuring out the functionality and then planning on going back and working on them later. That's why it's called player spaghetti, because it's very much a work in progress. Then I did the same for the mulking by adding an input AI. Now, I went ahead and attached this script to it, but what I did is I created a builder script so that every time we make new objects, so if I'm to bring a new boss into this project, we have that builder script which will automatically add this component to the object. Because of the fact that I already had the mulking set up, I didn't want to rebuild the entire mulking just to throw this script on there. That's a pretty simple thing to do, especially since there's no variables to fill at the moment. But in the case of adding more bosses, you might hear my dog drinking water, but in the case of adding more bosses, I wanted it to be the case that it would be automated. So within these builder scripts, which I don't think I've shown too much of, but one sec. Okay. My dog will do this thing where he will ignore his water bowl all day and then drink it all at once. But figured I'd mute for a second while he took some time to drink. But okay, so we have these building scripts which build all necessary components for the object, because the way this entire system works is that we have one script which adds necessary components to the object, because we wouldn't want every component to exist on an object which doesn't need every component. So what we do is only build the scripts which we need for this particular object, and we do that by looking at the parameters we've set up, which are like these parameters here mostly. So that informs how we build the script, and then after they're built, so this builds the prefabs which get reused again and again. After they're built, they need to be initialized, and that's where the initialization script comes into play. I won't show that simply because it's pretty identical to this, considering they follow the same flow. But I keep it very simple by having them all build right here. So if I ever need to add something in, I just throw it in like I did with the input script. Like I didn't have this here, I just wrote build input, then I went here, then I referenced one of the simple ones. I know biometrics is a really simple script, so I referenced this one for how to create a new one. Then I went ahead and created the build for that, which is pretty simple. Ones that are more complex are the animator. Like the animator is massive in what it has to do, because this is far deeper in terms of automation, because it's not simply just adding a script to an object. It is going through the imported object, looking at every animation, figuring out how to build actions based off the animations, and then rigging that into the blueprint animator, which we have to create an override. And there is a lot to the animation. I'm honestly really proud of it. I think it works really, really well, but not something to go over for today. So created this simple thing to build input. So now instead of having a hacky way to build the player input, we now have a way to see, is this a player? Add player input. Is this a nav agent? Add nav agent. So we have that set up now. So what I went on to do after that was I started up the AI, just very, very simply started up the AI. And we can see that here, where I'm currently setting up in a way to detect objects. Now, as I code this AI, it is not going to be the best it can be. I can practically guarantee that. But I'm sort of thinking out what functionality does it need to have to be testing the modular actions. First thing it's going to need to do is detect objects nearby. And it's not going to be just detecting the player, it'll be detecting any object. And then I went ahead and separated the targeting abilities, because there was just this action script which related to actions. But I figured targeting is going to be such a big chunk of code in itself that it should really have its own script. So we have these static functions for grabbing targets. This should really be renamed to get targets. Whoops, okay. Get targets overlap sphere. So this will get targets in an overlap sphere, which we can specify the origin and radius of. And then this one will get targets in a sphere cast, which is what we're using for the player's offhand ability. So I need to add another one. Well, actually, we can just use this directly. We're going to use an overlap sphere to get the radius and to grab targets for the AI. And yeah, so I'm setting that up. We're going to get AI targets. Once we have those targets, we're going to work on reading the calls from those targets. And then we should be good to start working on modular actions, which is going to be the most difficult part of the coding today. Okay, so what we're doing here is we've added to our optimized update loop, which runs on a fixed update loop that skips over a buffer period. So if we go to any manager, we have this value called fixed buffer time. So for the mole king, we have it set to 10, which is a bit excessive. We'll put it down to 4. And basically this means how many fixed delta times will we skip. I actually have a tooltip you can see here. This value is multiplied by time.fixed delta time for looping opti update. So this will be our optimized update loop, meaning it runs 4 times time.delta time, time.fixed delta time, which is, I believe fixed delta time is 0.02 seconds. You can actually change it within your project to be whatever value you want. So for instance, if you wanted it to be 1 second, you could do that. But I leave it to the default, which is like a rough value for the average passing of a frame rate. It's good for calculations. It shouldn't be used for time-based things where you actually need to be tracking time. It's better for calculations, then this is the exact case where that's useful. So I have a customized optimized update loop, which runs less calls than a regular update loop. And then we are going to detect objects. When we do detect objects, we are going to get an overlap sphere using ourself as the origin point and a detection radius, which we have set to 30 units at the moment. From there, we will map the IDs from the managers. So this will grab the unique IDs of every manager and put it into an array of U shorts, which will be easier to track through than entire managers. So we're going to go through this array, and if it's not already added to our tracking IDs, we're going to add it to our tracking ID. Then once that's finished, what we're going to do is detect objects and I have it detect objects because it's part of this, but what we're going to do is cull lost objects. So what we're doing here is we're making sure anything that's no longer detected, we are clearing from our list. So the very first thing we do is, are we passing in null here? So for example, if I just wanted to clear this at the end, I could just throw in null, and I want that to work to just clear this. So first thing we're doing there is to set up a case that if it's null, just clear it. Next thing we do is if it's less than or equal to 1, clear it. Now, the reason it's less than or equal to 1 and not less than or equal to 0 is because the array element 0 is always going to be itself. So the benefit to using my slightly more customized overlap sphere of getting targets is that it also puts ourselves as the origin. So let's say for whatever reason we want to do an action that should affect the player, well, not the player, the initiator of the action as well as its targets, then we want to be able to have that reference. And so we can easily do that by having it be the first element of the array. It also ensures that we never have an empty array when we're returning from this. And you might think, well, if this thing is the one initiating the action, surely it always has reference to itself. But that's not always true because of the way the modular actions are set up. The actions won't have a direct reference to the manager which is calling the action. You can think of it as using a static method. Static methods have no idea of context. They need everything passed into them. The only references they can have outside of their localized scope is other static variables. And so obviously the player acting in the scene currently is not going to be a static object. So when we pass this in, we need to pass in what is currently the origin of this attack because we don't have outside references. So we need to know who is starting this. Obviously this is just getting targets, so it's not needed here, but the actions, which will also be static, need to have a reference to the originator of the attack outside of just the general scope of that object that is calling the action. So that's why we pass in the origin. We always have it set to the first element of the array. And then we always can grab a reference to the object that is initiating the action because we know the first element of the array will be the originator of that action. That way we don't have to also pass in the manager. We can just pass in the targets and then look to that for the the object calling that attack or action, because actions aren't just attacks. So, okay, that's that explained. We're going to call the objects and clear. Now, what we do here is we get our list of current tracking IDs to an array because we're going to be iterating through them, but also modifying the list. So you never want to iterate through a list that you're going to be modifying, or else it'll mess up the entire for loop. Because I mean, if you think about it this way, you're iterating through each element of the list. And if you're going step by step through every element of the list, but then all of a sudden you remove one of those or add to it, it's going to mess up the logic of this loop because it now doesn't quite know what it's iterating through because now the values of that list have been changed. So what we do is convert it to an array that will be static for the purposes of this method itself. Like it's not going to change in this method. And then we iterate through, we see, do we find a match within the past object? So these are the objects detected on this iterate check. So that optimized update loop, this is what's checked on that optimized update loop, the IDs. And then if we've detected objects, we go through it and we see, okay, for each tracking ID we have, so existing ID, for each existing ID, loop through the found objects and see if that existing ID is equal there. So the moment we find one, we set this to true and we break because there's no point of checking for more because we already found our match, and there should never be duplicates. I have checks in place so that never happens. And then if it's not found, we remove it. If it is found, we don't need to do anything. So now this is set up, we can go ahead and test it, and we should see the AI grab objects in the scene as references. Okay, so we can see here that the AI has added 3 IDs here. So we have 60,000, 41,000, 8,000. So next thing we need to check obviously is if these are actual IDs. So we can look here, that's one, and I would assume this grass is one. Okay, so we know the AI is correctly checking 3 different types of objects. So again, I've talked about this a lot, but I can't explain enough how I guess proud I am of this system and how it helps to make me make this game. It's not a given in game development that you will have every object be linked in such a way that any object can look at any type of object and see it as the same thing, if that makes sense. So obviously these are all game objects, but they have more to them than just being a game object. They have scripting to them, they have functionality to them, they have purpose within the game itself, outside of the context of just being an object. Now in most games, at least the way I've worked on games, I can't speak to how the industry works on this, especially more experienced people. But in my work of making games, these objects, the player, the grass, and the barrel, would all be separate scripts, which share no overlapping code aside from like just sheer coincidence that the code looks the same, but they're effectively unique code. So this check here where we're iterating through each object and getting all of these objects and then have this list here where we have the IDs of each of these objects, that is not something I could have done before because these would be 3 different things where we need to check for each one of these types of objects and then add them into 3 different lists because these are different types of objects. But because of the way I set up these objects to always root from the same base with their own customized scripts on top of that, what we're able to do is treat them all as the same object, get these unique IDs that we've created using use shorts, which are like smaller than integers. Those sort of things don't really matter that much, like using a use short instead of just an integer. It doesn't matter that much, but because of the replay system, which is going to be saving IDs into a JSON file, that's really where this optimization comes in. It's not in the real-time performance, but in the size of your save file, because save files are going to get quite large, and if we can cut down on them even just a little bit, like if I did integers, these IDs could be like I want to say 12 digits long. I can't remember off the top of my head how far an integer goes, but because they're use shorts, they can only be a maximum of 5 digits long, and I think the max is 65,000. Like the highest number this could be 65,000, which is more than enough for objects in the scene. If there are 65,000 objects in the scene, I don't think the game's going to be running. But we also have checks for that as well. I have a failsafe in place that if the IDs start capping out, because I have a system so that IDs can never be equal. Like I'm not just relying on sheer luck to make that true. We actually check if there is an existing ID that already has this number. And if there's a fail safe, which I believe is 100 tries. So let's say we're trying to grab a random number for a new ID, and we do that 100 times and keep getting IDs that already exist. We have an error that gets thrown that says we are close to, if we have not already reached our max on IDs. So we ought to change this value from a U short to something bigger. But anyways, the main point is I'm really happy with the fact that all of this work paid off with the adaptable objects to be able to do stuff like this where we just seamlessly track IDs of very different objects. So now I'm going to test moving the mole king around and see if he loses that. Actually, let's see if we can change this on the fly. Okay, we can. So we changed the detection radius to 5. We could also test and draw this out, which probably would be a good idea for the AI. Let's change this to 10 and get a bit closer. So now we have the ID. I would assume that's the player. Yeah, we have the ID of the player. Now, something interesting here is that we aren't grabbing the main hand and the offhand. The reason for this is because these are on the default layer, and we don't detect objects on the default layer because of the way we've set up these specific get targets methods. So we only grab objects, player, living, element, terrain. Probably shouldn't even grab terrain, but for now we do. Actually, no, we should grab terrain because stuff like rocks we could track. So, all right, we're successfully grabbing the IDs, which is just the first start to making the AI functional. So now we're tracking these 3. Now, the next thing would be to, the temptation for me is to set up moving towards a target and looking at a target, but I'm thinking it doesn't make sense to set up that code until we have the actions working, because if I want to keep the mentality that the AI can adapt to any sort of object it needs to be attacking, then we can't simply say move towards the player, because obviously the easiest setup here would be to, in the code, go through our iterate targets. So let's go back to the AI. There would be something like move towards player, and we would look through these iterate targets for a player. And we could do that by just finding an object by ID. Look until we find something that is a player, then follow that player. But that would be a hacky way to start it. And maybe it would be a good idea to do that just to make sure we have the movement code set up correctly and rotation code set up correctly. But I've tested, actually, I can show right now that we've tested that stuff and it works. We can go to rotation data. What we can do is take the ID of the player, this one here, and we can plug this into the rotation, and we can set a look target ID here. We can change this to completion. We can change rotation type to look and axis of rotation up, angular speed 45. Now, I believe this will work. Now, I've been wrong 100 times when I say something will work, so let's just test it and see. Okay. He's looking. Test it again. Looking. Test it again. Looking. So, again, something cool about the adaptable objects is everything works within these fundamental calls. Like this exact code, I could copy this rotation data and throw it onto the grass plant. Well, maybe not, because I don't think this has... No, it does have a movement script attached. So we could do something like this where we go completion, same stuff, rotation angle. Oh wait, no, we're not using that right now. We want to do look, angular speed 45, up. Now, I'm not certain this will actually work because I don't know if this has the code to actually rotate, but let's see if it will. Okay, there we go. So even a plant can rotate towards the player. Oh, what did I do here? So it looks like we're not stopping rotating. It's kind of cool, the calculations you can see happening there. This is the cross we're using to get the direction towards it. But I don't know that we're actually seeing it rotate. Let's see. Okay. Now the rotation still needs work because it has an issue. I guess it's really not an issue. If something's around it, it'll turn one way or the other way, but I guess it really doesn't matter that much because who cares if it turns one way or the other? If it's got to go 180 degrees, it doesn't matter if it goes one way or the other. But I think we're good. Maybe it's because the duration's 0 when it should be infinity. Okay, so yeah, we got that working. So yeah, these calls can be made on anything. Like I could do it on the barrel as well. And we can do this again, do rotate. You can see it going towards that. There must be something wrong here that it's still calculating despite the fact that it is no longer actually rotating. But that's a problem for a later day. Anyways, we show there that, actually, here, let's do it again just with movement too. I'm showing here that I was going to say we could set up testing for moving towards the player and rotating towards the player, but that's actually extremely easy to do because we already have this within the testing of the adaptable objects that anything can look towards anything. Let's grab this ID and hope it's the player. No, 21,000, okay. This one here. So this ID is going to be the player, and we can just do testing here. We can plug in the move target ID of the player, do target, completion, move target, or white movement, it doesn't really matter. Is self, no arc, duration, we can do infinity, speed of 10, do move, and we're moving towards the player. So you could see how easily we could set this up within the code. Now, one problem here is we're not stopping. Although, actually, no. The reason we're not stopping is because we set a destination. So this does make sense. The AI sets a destination. And so it makes sense that we just keep moving back there because the AI is saying it wants to get back to where it was. Now, setting this up would be extremely easy. So we can do that right here. Let's go ahead and throw in private void follow player. And so what we can do for this is for each uShort ID in detection tracking IDs. And so if this is empty, it'll just not iterate through this. What we're going to do is we're going to go manager gm.find, no, .ao managers .find manager by ID, plug in that ID, and then we're going to go if okay, so we have this set up that it's a Boolean and then it can out a found manager. And the utility of this is that you can have a check like this where if we find it, then we use it. So if we find this manager, then we will do found manager. Well, if found manager as AO active manager is not equal to null, then we're going to do this. If found manager as AI dot movement type is equal to movement type dot player, then do manager dot controller dot call event rotate, and then we're going to do a new utility rotate. We're going to want, do I not have, maybe I don't have it set up for this, because for movement we can do this. New utility AO, and then we would do directional targeted. So we would want this, and we can just follow along. False, duration 0 for instant, infinity to move towards target until reached. Math of infinity, use short ID. We're going to plug in that ID we have there. Then we're going to do float speed. Speed we can just throw in 10. Then we're going to want arc. Now to get a arc that is just simply blank, we're going to do move. We're going to do utility AO move arc data empty. It even has it auto completed there. And then we are going to do false to wipe movement. Okay, and we're going to do one more thing, which is we're going to want we're going to do I'm trying to think how we can track when this finishes, because we're going to want to actually, here's what we can do. Let's throw in a quick float of follow time equals 1. Follow time equals 1. Instead of infinity, we can do plug in 1 second. So the way this should work is that it'll do it to completion, but also just until that duration is reached. So it should only do it for 1 second. Then we can do, if we're able to do this call, then do no, let's do this. Okay, follow time current. Well, okay, let's do okay. So if we are not following, then let's go ahead and try to follow the target. Else, if we are following, do follow time current plus equals time.fixed delta time times manager.fixed buffer. So we know this is the time we're waiting on the optimize update loop. We can throw follow player onto manager.update update loop plus equals follow player. So now what should happen is we move towards the player. And let's see if that actually works. And there we go, we're moving towards the player. We kind of push them around. And so we've stopped here. And I would assume I know nothing. So let's see. Oh, we don't set it. We don't have a way to stop falling. So what we want to do is we want to have else if follow time current is greater than follow time max. Then what we want to do is following equals false. Okay. Now we should have something to stop moving towards the target. So let's do that. And now we're just really bullying the player. Now that probably has to do with the AI stopping distance. If we change the AI stopping distance, that should fix that. Yeah, stopping distance is currently 0. So let's see what happens if we put that to 1. Because it's just setting the target. Nope. Okay. Let's do it to 4. Also, this was like super high. Okay. 10. It's weird that the stopping distance even is not working, despite the fact that we are. Let's go ahead and see what happens if we disable this. Okay. Now let's go here. Oh, it's because I don't have it as a self movement. That's why. Okay, true. That's why it wasn't stopping, because we were pushing it rather than just moving the AI. Okay, so let's go ahead and do that again, and then let's go to this. Let's do stopping distance more like 1. Actually, there's a big boy. Let's do 2. Okay, and now he should actually stop. Okay, now he stops very soon. I think it's because it's an iterate movement. All right, well, that's something we can work on later, but the idea there was just to show how we can set up following the player, but we don't want that right now. We want to do something else. That is an issue we're going to have to deal with later, but I just wanted to show how all we have to do is throw in a move call, and then we'll follow that player. So same with rotation, we just throw in a rotation call. What we should do right now, though, like I'm okay with pushing this off till later. What we should do now is set up those rotation events. So I was trying to do rotate. The problem here is we don't have cases set up for creating rotations for each type. So in the move, we have detailed specifics for creating rotation datas, but we don't have them here. So rotation angle, we should say so for creating an angled rotation angle the degree of rotation to move. So like rotate this many degrees. Axis of rotation, about which axis are we rotating? Okay. And then is global, should we use the values for axis? Okay, so now we have that. We want to do one more, which is going to be for a targeted rotation. So instead of a float rotation here, what we're going to want is use short target ID. So we're going to want look target ID will be that, and then this will be 0. Okay, so now we have a setup for both of those. Okay, let's change the last param here. Okay. We'll have to do some more there for durations, but that's better for now. Okay, let's get rid of this because we're not actually going to do it this way. We're going to need a detection radius there, but we can get rid of all of that. Okay, I think that went a bit longer than I expected for explaining what we're doing here, but we have the AI set up so that it can track nearby objects. We don't have collision being a factor into that, so that's something we'll add later in terms of if we're blocked, we should no longer be tracking an object. And what we'll do for that most likely is we'll have one array which is detection tracking, which will be specifically objects we should be keeping on radar, and then we will have like seen objects, so SEN, not SCNE, for stuff we can actually see, or maybe like here. And so then we have some information on it. Or that could even be within, actually I think this is the better idea. So when we're doing that thing where we're checking whether or not an object is attacking, what we should do within that is when that call happens, we should detect whether or not we should be able to see it or hear it. So you can think of it as an AI always knows where you are, but they're pretending whether or not they should know where you are. Because it's often the case, at least I'd assume so in the game development I've done, that the AI always knows where you are, but it has checks in place to see whether or not it should really know where you are. So let's say you're behind a wall and the AI is behind a wall as well, and you peek out of cover to shoot the AI, and the AI stays behind the cover because it doesn't know you're shooting, even though it does. So when you're about to fire, now I'm not saying this is how games actually work, but it's how I would design it. While you're behind that wall and the AI can't see you, we have it in a cache where you are. Well, at least the ID of your object, so we know you exist. Because there's no point of getting rid of you when you're most likely still in combat with us. And so we keep you there, but the moment you peek out of cover to fire, that fires an event that says, can we actually see you right now? Do we know this is happening? Well, when you're getting ready to aim, no, because we can't see you. But when you fire, yes, because we can hear you. And that's how I'd set it up. So I think that's interesting for people who may not know anything about game development, is that AI often are much smarter than, well, they have more information they deserve, and then they have checks in place to make sure they don't abuse that information they have on you, because they can see everything, and then it's filtered down to see nothing. Anyways, I think what I need to begin on now is having the AI detect that an action fires from the objects it's tracking. So I'll get started on that. Okay, I want to go over for a second what I'm doing here because it is a bit convoluted. Well, it's complex, but it's convoluted because I don't have it organized as it should be. So I'm going to work on making a new script here to kind of clean up what's going on. But I'll explain real quick. So what we need for the AI, in order for the AI to know when an object is firing an action, and that's specifically a animation, well, you can think of an action as anything an object does which involves changing its animation state aside from collision actions, which are a unique case because collision effects don't change animation. Well, they can, but they don't inherently do that. But everything else is an animation, and any of these can have a deliberate action attached to it, and that action can have a list of effects, and we can see here that this one has no action, so it wouldn't be firing anything. Same with this one, same with this one. So there's checks in place to make sure that the action actually has stuff attached and has effects with it. But what we needed to do was set up an event so that when this actually fires, the AI can attach itself to that event to react to that action. So what I did here is previously this code here, this line here, was firing this method. So if we slap this here, do action data, get rid of that. This is what the code looked like before. Just fire that action, don't call an event or anything. But what we did is we set it up to now fire a call, and so this call gets fired, and really this should be private because it's only going to be self-referential. And then it's going to fire this event called fired action event. Now that'll fire this, which is going to do all of the mechanics of that event. So for each effect, we're going to fire. Now, within this, we make sure that it actually has effects because it's possible for something to have an action but have no effects. So we make sure that's true. Now, what we're doing here is we're calling an event. And now that it's an event, what we can do is go up here. And so we have, in the very beginning, we attach ourselves to it with our personal actions, which can look to whatever the action is and then do the code to perform that action. But now that it's an event, what we can do is go to the AI. And what we could do here is, I'm just going to throw it in here real quick just to show how this would work. We would do, let's just throw dummy target. Okay. I'm just doing this for the sake of demonstrating. Obviously, this wouldn't be an actual target. And what we're going to do here is say dummy target dot action state script dot fired action event plus equals, and then we could have something here called private void listen to actions, and then take in actions.action data initiated action, and we could attach this to this event here. So now we have fired actions is listen to actions, and now what we could do here is parse this information. So we could say something like if initiated action dot benefit type is equal to negative. Okay, well this is a bad effect, so we want to move away. Well, check if attack action will hit us. Then after that, what we want to do is say move away from action, or stay still because the action is not going to hit us. So this is where we can start doing stuff like reacting to this action. So hopefully it's starting to become clear why I need to do these modular actions, or not need to, but why I want to set up these modular actions to where we can take a list of parameters from this action and decide what to do from that. So we can also, from this action, but I need to build more to this, but we could do something like actions dot action data, and let's just do this in comments because this doesn't actually work yet. We do something like get targets, and this would be something where we look to what's on this actual initiated action. So we would pass in like this would be a static method on the action data that can take in some action data and then get targets from that. And so we could say like, all right, targets equals this. And then what we actually want to do is do something custom where we do get targets, but we want to feed in like maybe a vector 3, which is origin, and then the action. So this is where the action will be initiating from. It takes all of the information of that action and then gets the targets from it. So we take these targets and we say if targets dot contains this, which this is, well, let's do this, manager, so which is going to be us. So if it contains manager, then what we want to do is move away, or like just decide action, or like have a bool that says is are we target. Maybe that's a bit ugly, but are we target equals true, something like that, and then we can figure out what to do from there. So what we set up is a way for the AI to listen to this effect, and we can do something like here, do not log an error saying test the action initiated by, and perhaps we'd also want this, right? We want listen to actions and I'm thinking we want to know which object this is attached to, but we don't want to throw in, we don't want to pass it into here, because like if we did that, then really like it's adding this just for listening when the originator of this doesn't need that information. But I think what we have is we can do that. This is just for debugging, so it doesn't matter if that's off. But initiated action by root is of benefit type, and then we could do, well, I guess, sure, let's just go ahead and do this, plus actions initiated action dot benefit type. So we could do that, get rid of this here. So let's actually just set this up real quick for testing, kind of showing what I'm doing. I want to go over how I need to clean all this up, but actually it won't be too hard to go over how to clean it up, but I want to show how this will actually work. So we have this detection set up where we detect objects. Let's set up another thing where we have a region called listen. I guess we should be more specific and say listen to actions. And we're going to have a method set up here, which is, I mean, it's just literally this. So let's go ahead and slap that there. Listen to actions. We're going to set this up along our optimized loop. Actually, yeah, okay. I was thinking maybe we wouldn't want it there because we're going to be checking every frame for this stuff, but I realized we're attaching to an event, so it doesn't matter if it's every frame because we're firing along with the event. So we're going to want listen to objects here, and actually, we want to do this. Private void begin listening, and we want to do optiloop begin listening, add that as well. So what we want to do here is we're going to iterate through every single one of our IDs, in detected tracking IDs. And then what we want to do is if, well, first we're going to want a reference to this. AO active manager, actually we can do base. AO base manager, if I can type, okay. AO base manager iterate target equals manager.gm dots find .ao manager find by ID, and then we actually want to do this. If we were able to find that, then out iterate target. Okay, so if we're successfully able to find that target, then we want to do is iterate target dot iterate targets if iterate target dot what do we want to do here? If iterate target animator type is equal to, actually, let's do this. Do that to convert it to an int. It's greater than 0. Then we want to be listening to this. So what we're doing here is we're seeing whether or not it's not static. So this animator type, if we go here, it's going to be static, cosmetic, or full. This is going to be 0. So this will be 0, this will be 1, this will be 2. Anything with a static animation is not going to have any actions to do. So the only other thing we need to check is movement, and we're going to do the same thing for that. So if if the iterate target animation type is greater than 0, or if the iterate target movement type is greater than 0, so what we're going to say here is check if the object has any actions to commit. Okay, so what we're checking here is something like a player is going to have an animation type where it can do actions, and something like a barrel, which has no animation but can maybe blow up, like an explosive barrel, that'll have a movement type greater than 0 because it'll have a rigid body, which is allowed to check for collisions. Because collision is not added to static objects, because why would a static object have collisions if it can't have anything happen to it because it's static? So yeah, animation type, it can be a static animator, meaning it doesn't, well, yeah, it can have a static animator but still do an action if it has a movement. So we check, is animator type greater than 0, or is movement type greater than 0? And that should cover our basis for only grabbing objects that have actions to them. Next thing we want to do is if iterate target as AO active manager is not equal to null, then what we want to do is AO active manager iterates AO, well, iterate active equals iterate target as AO active manager. So now we have that, and what we want to do is say iterative active dot action state script dot event fired action event plus equals listen to actions. So what we're doing here is we are going to add this to our list of actions. Now, one more thing we need to do is that we need to stop listening to actions. So we should have another one here called stop listening. And this is going to fire, we're going to take in a useShort ID of some object that we want to stop listening. And I guess we should do that here, right? Because we, instead of doing this iteratively, so let's actually change this not to be iteratively, but instead when we detect a new object. That'll be better for performance. So instead of doing for each, let's pass it an ID, and then do this here. Now we can also make sure that, well, by doing it this way, we're making sure we're not adding something that's already added if we do it like this. So when we detect new objects, when we do an add a new ID, we can also do this, begin listening and add ID. So now we're beginning listening and we add it there. Okay, so now we have that there, and then what we can do is when we call a lost object, when we remove an ID, we're going to want to do this. We're going to want to do if it's found, we remove it, do that, then also do stop listening ID. Now it can be the case, it could be the case that what we're passing in here isn't actually being listened to. But what we'll do is go through these same checks again. So how about we do something better and do private void can object commit actions, and we'll pass in, we're going to need to pass in use short ID. We're going to need this to be a bool, and then we're going to need to out a AO active manager. We can just go ahead and say active manager. Okay, actually let's do this, target manager. All right, now what we're gonna do here is we're going to take this, which we had there. Actually, we're gonna take all of this except for this part right here. We want to leave that there. And what we're going to do is we're going to take this out, throw this into can object commit actions. We're going to go here. We're going to find by ID, then check if the object has any actions to commit. And instead of doing this here, what we're going to say is target manager equals that, and we are going to return true. Now, if nothing else happens, we're going to do this and say target manager equals null and return false. Okay, so now we have that set up. We can go ahead and throw a description here. Check if the parameter ID can commit any actions. Okay, and that's pretty self-explanatory, so we're going to leave that out. Now we have this here, can object commit action, so we're going to say all right, and then we're going to do the ID we're taking there, throw out target manager. If we can't commit actions, then add it in here. Now what we can do for stop listening is the exact same thing, except minus equals listen to actions. Okay, so now what we're doing is we're adding this method to every target that can be listened to. Now what should happen is we can fire and see the action and then parse whatever that object is doing. Now one thing I'm thinking is that an issue we have is we don't know what object is committing this action. I mean, we can rely on origin root, but I don't know that we actually can, because let's see, like origin can be null. So if an origin's null, then it's not going to be working. So it either needs work here or we need to find another way to do it here. Because at the moment, I mean, even this could cause errors because the root could be null. Although it's not set up, the action we're testing is not null. But we currently have an issue that we don't have a way at the moment to link the target manager that we're listening to as well. So I'm thinking what we could do is have a dictionary entry. No, that wouldn't work. What we could do is spin off objects that are called listeners, and these listener objects are given an active manager that they're tracking, or maybe just the ID of the active manager, and then they have the event of listening to it. I'm thinking we could do something like that, but I don't know if that's more work than it's worth. At the moment, this will work, and then we can look further into whether or not we need more information and whether or not we can turn this, or we should turn this into an object itself. Because I think that would work as a solution. I think something we could do is, what is action data used for? I don't know how long ago this was. What's action data used for? Action data is used for firing an action, and an action can be literally any methodology that an object can do. So for example, the player attacking does a pushback on any sort of object. That's action data. So an action data describes first what an action will do. So it has parameters in terms of what this action does. It has the information needed to grab targets. So, well, I guess I should say it will have this information. It doesn't at the moment. It will have the information needed to grab targets, and then it will perform the effects. So we have the effects here. It'll perform the effects that need to happen. So it has a way of grabbing targets, informed what the action does, and then performs the actual like mechanics behind the action. The reason we need this is for the AI, so an AI can read this data and understand what is going to be happening to it, and also whether or not it'll be hit by it. So you can imagine a case where the player is jumping. That's not really going to damage the boss or the AI in any direct way. So the AI could see that the player is jumping and then just decide to do nothing. Alternatively, the player could be doing an attack. The AI can read that as a damaging effect. It can see that it can read that the player's targeting. Well, it can siphon off the action data script to get the targets that it would be getting, and then see that the AI itself would be one of those targets, and then move accordingly to that, or attack the player if it can hit the player before the player hits it, in which case it would cancel out that action. So the action data serves as a way to give information of an action, which an action can be just literally anything that happens in the game, a way to give that information to an AI. That's the entire purpose of it. Okay, so back to listening for actions. I think what I could do is create objects where we have an object that is like a listener. We attach that, we create that object whenever we do this. So like instead of doing this here, what we would do is like create listener object. So we could like create listener object here, and then instead of doing this here, what we would do is we would pass in active manager and attach listener to action event. So what we would do here is like initialize an object, and then it would know which manager is attached to, and then it would be listening to those actions. Then what we could do is whenever that fires, we have a reference to the AI itself, and the AI can feed in information that the listener needs, like what actions are available in retaliation, or call an action on the manager, like do this action because we're about to be hit by this thing. And then also get information like, well, the additive information of what object is attacking us, because we probably want to attack the object that just attacked us, because listening is purely reactive, whereas we're also going to need proactive as well. But yeah, currently we're just focused on reactive AI at the moment, but I believe this will be okay for now. So what we can do to test this is we can simply do this test here. The action initiated by throw out the root name is of benefit type, and then the benefit type. We can go further, and I think what would be best to do is work on the targeting type. And so then what we could do is like, we would do here, siphon targeting data from the action. If we are hit, log we will be hit. Well, if we would be hit, log that we're hit. If we won't, log that we won't. So I think this is a good place to start working on this stuff, because I'm thinking what we ought to do is, well, what we could do for testing this stuff is start with getting the targeting. Then we can work on, is this effect a negative? Move away from it. If it's not negative, move towards it. And that's going to be pretty simple, because here's all the information we need for that. we need the parameter from the action of the benefit type. We need to get targets from the action. Then we need to get the position of the origin of this attack. And actually, maybe we don't need to know the manager at all, because we really just need to know the position of origin for the attack. And if we know the position of origin, we know to move towards or away from that attack. And then that can be besides the point of our proactive attacks, which will be on some target, most likely the player. So yeah, perhaps we don't need to know the origin. Anyways, what we could do is we just need a vector position of where this attack is originating from, or even where, like, if you think of a ranged attack, like let's say it's a spell that has an AoE that starts 10 feet in front of the player. Well, our origin then isn't the player, it's the origin of the sphere that's creating that AoE effect. So we can move away from that or move towards that. Now, this could get more and more complex for stuff like, okay, well, we want to move away from this, but we also want to get closer to our target. So what if we move away and get closer to our target? And that's more complex stuff that we won't be getting into now. But I think this is a good foundation for testing out the actions and making sure they work as they should. I also should say that I'm going to go back on mute and just start working on this. Oh, except one thing I want to do before we hop into this, I'm getting ahead of myself on continuing forward, because one thing we need to do is this script on the right is our collision script, which handles differently fired events. So at the moment, we're not listening to collision events, and we need to be listening to them, but they fire differently than effects because of the fact that they rely on collision data, which actions don't need. So it'd probably be too much to go over how exactly the data of a collision action is different than a regular action, but to put it simply, there is data needed that the actions don't need, and so they run differently in their code. And it should still be firing that same event. So what we need to be doing now is, what I'm thinking is this action state script has ballooned quite a lot. It's over 500 lines of code, and it's not really the length of it that matters. It's the fact that it's essentially serving two functionalities. It's serving the functionality of changing the state of the action. Well, changing the state of the object, so going from idle to death to hit to forecast to action to post action. It's doing all of that, but it's also managing actually performing actions. And I think considering the fact that we need to have this be an event that can be listened to, and we're adding more functionality to this, it would probably be better to create a script specifically for performing actions. So we could call it AO perform action, something along those lines. I think AO action would be too confusing because we have action state, and we should probably just have another script like perform action. I don't know. The naming is a bit tough here because action's quite a general term, but it also needs to be general because it is general. So I'm thinking, yeah, we need to add another script to get this specific stuff onto its own thing, so that it's not this mess of two different functionalities going on here on the action state script. So my goals for the next, I don't know, hour of working on stuff is I'm going to be separating out the action effects specifically away from the action state script, because not every not every state is going to have a corresponding action. So separating that out, then creating the event fire so that it can filter out whether this is a typical or a standard action or a collision action, in which case we need to treat it differently. So that'll be a case of having the having a general method, which is fire event, which is specifically for an object actually performing the action, not something listening to it like the AI. And then saying, if it has impact data, well, if it's an action of collision type, then do this functionality. If it's a regular effect, do this functionality. That's pretty easy to do. It's like doing this stuff here. So I'll be doing that, separating that code. And then after that, I will be working on setting up the listening for the AI, and we can test out we need to set up a way to get targeting from the action because currently that's not set up. So we want to do getting targeting for the action data. Then after we set up that, we're going to do making the AI listen to the action and then move away from the action if we're in range. And if we're in range and it's a negative benefit type. So let's say it's a positive benefit type, like the AI, like let's say there's a healing aura that's created by the player or some object, but it heals anything, not just the player. It heals anything that comes into range of it. And so the AI says, okay, this effect that's going off right now is beneficial to me. I'm not in range of it, so let's move in range of it. And so that's what we're going to be setting up. So separate the scripts into their own classes, create targeting for action data script, set up reactions, set up the first reaction for the AI. Okay, those are the three things. I think I'll explain for a moment what I've done. So I went through and added a different script. Get rid of these. I went through and added a different script called AO performing actions, AO being adaptable objects. I don't really like the name performing actions, but currently I have action state and performing actions. So at least they're different, they're distinguished. But that's beside the point of what the actual functionality is here. So I set up this script, did the basic building and initialization, which is pretty straightforward for me at least. So I won't explain it again because I think I've gone over it before. I set up two events, one for a standard action call and one for collision, because I realized the collision is going to need impact data, which is two things colliding together. And I just basically moved some stuff out of action state that had to do specifically with performing actions. So action state is changing animation state as well as triggering actions. And then actions, I just wanted to handle the present actions which exist on that object because every animation needs to have a corresponding state, but not every state needs to have a corresponding action, if that makes sense. So you can see here the Mole King has, well, I guess, yeah, okay. So he's got, these are specifically actions. So he's got actions for these particular states here. Well, states combined with their variants, but it goes forecast, action, post action in terms of animation. If we look at the animator here, forecast, action, post action. Now, obviously we don't have that for every action because we don't want to do anything on action, post action. We just want all the data to be in the forecast. So that's why I separated those out so we could have a differentiation between the state of an object and then the actual like mechanical actions of an object. So I went through and added these things back in because when I switched it over to this script, it wiped all the data. I'm thinking I should either save this stuff to JSON so that it's permanently saved and we can always rewrite it, or, and I mean, they're publicly exposed classes, so that should in theory be possible because if they're shown here, then they can be saved to JSON, but sometimes there's complications with that anyways. So maybe that wouldn't work, but what we could do is also make them scriptable objects. I'm not sure I want to go that route, but it is an option for making the data stay permanently. Actually, even a scriptable object, if I change the variables, it would still wipe the data. So yeah, I don't know. It's only an issue when making the game. It's not an issue when the game's made. So it's not too big of an issue right now, but I guess it would be on me for creating more objects in the game when I don't have the systems finalized. Like the objects I have in the scene right now are the essential objects to represent 4 different types of things. Like the reason I don't have more objects in the scene right now is because I don't want to have to deal with changing more objects than I have to, because grass is something that can animate but cannot move. The Mole King is an AI. The player is a player. And a barrel is something that can move but can't animate. So we have essentially the 4 main types of objects you'll see in the game. And I mean, there's static as well, but like, I guess these are technically static, like these cubes. But I'm just testing with the basics of what we need. I don't want to go any further other than that. anyways, that's branching off of what the point of me explaining this stuff was. I just separated these scripts out, and then I went through and I'm testing to make sure I've reset up the actions, and hopefully this will kind of explain what exactly goes on. Actually, I didn't set up the grass, so let's go ahead and do that one as well. This one I can go ahead and take the mole kings, slap it on here, and then get rid of the extras. So this won't have any of these. So let's delete that. I guess we can just go here and go minus, minus, minus. Okay, so this is only gonna have hit, idle, death. Nothing's gonna happen here, but for collision we will have this alter health. So alter health will automatically, what it does is it calls the biometric script and takes 1 point of health away. And when 1 point of health is taken, we trigger the hit state, which will play that animation. So what we should see here is I'm going to test hitting the plant, hitting the mole king, hitting the player. Now the player doesn't actually have any hit animations, so you won't see anything there. But if we were doing input, you would no longer be able to do input. And then the barrel, we're going to fracture that. So we're going to be doing a collision on the barrel. So we're going to go here and I'll start testing this. And I will show, if I set this up right, we'll go 100, 100, 100, negative 100, negative 100. So essentially what we're doing here is we're simulating a collision. So imagine if this barrel was speeding this way, like going that way, and then some other thing was coming towards it, and they smacked into each other. So one's going 100, 100, 100, one's going negative 100. Well, this is extreme, but anyways, we do collide and it fractures. So that's working as intended. Let's go to the mole king and let's test to see if we do the same thing here. He should get hit. So let's see if that's true. And he gets hit. Okay, cool. And then let's see the player. Now we go to the player. Now only the legs can be hit because the legs are essentially the only living part of the character. There's the main hand and the offhand, but those are effectively animators with no life to them. In terms of being hit, we're going to coordinate that through the player script particularly. The reason I'm not trying to do any sort of modular code with that, like how everything else is adaptable, is because it's specific to the player. Nothing else is going to have 3 objects attached to it, at least at the moment. So I don't have any plans for doing stuff like that. So, okay, let's test this out here. 100, 100, 100. Again, we shouldn't see anything here, but what we can do is go ahead and clear all of this. And also, this is testing that we actually set this up properly. Like, if we hadn't set up this collision here, so we've moved the collision code here onto this performing action script, whereas before it was on the collision script particularly. So now we have all of this performing, all of the methods for actually mechanically performing actions are now all in the same script, rather than one being on the action state and one being on the collision script. So because we actually saw that fracture happen, that hit happen, we know that it's actually firing this event. So that's good. We should see, if we were to search for this, well, we cleared it, so we wouldn't see it. But okay, so let's go ahead and do this and do collide. And you can see here, it's actually handing of collision event failed. Impact velocity of both objects are not notable enough to run event. So what's actually happening here is that the call is failing because it's colliding with the floor, but it's like so minimal that it doesn't matter. Like we're not actually calling that. So if we were to look to the game manager, you'll see that the event history, it's not like it's failing with 19,000 calls of hitting the floor. So that's good. One thing we should make sure though is that this, no, that has to run on update. I was thinking we could move it to update, but no, gravity's got to run on, or maybe we could, might be able to move that to update if we fire it over time. But then if we fire it over time, yeah, we can't do that. Okay. The player is a unique case where we can't change that to an optimized update. Okay, so, all right, what was I saying? These rotation events are going to be cached. Good. Now let's go to the player and fire this event and hope that the player gets hit. We'll look to this to see that it happens. Okay, and we can see that. All right, so we have our collision event, impact force 30,000, quite a lot, was greater than threshold 10, triggering the effect. found action hit to match state, hit, triggering hit, handle event biometrics. So this here is storing for the replay system. So storing that we changed states, storing that we did damage, storing that we collided, storing all of that stuff. Okay. Now we're going to switch to hit. You can see that happening here. And then we're switching follow-up state will be hit to idle. So once hit finishes, go to idle. And now we're back to idle. We can actually see that if we go to test state, well, actually, let's get rid of that. If we go to action state here, you can actually see that happen. So let's go ahead and test another collision. Do collide, and then let's watch. You can see this go to hit. Hit, idle. Actually, I guess I did put a temporary animation there, so you can actually see that happen. Let's do collide, and then unpause it, and you'll see the legs go back a little. Now we still have to link that to main hand, offhand in terms of just visuals, but yeah, we've got this set up now. Everything's back to the way it was, but we've just kind of separated that code out, so it's a bit more organized in terms of, I felt like this script was ballooning too much, so I really wanted to clean that up and get the action separated. Okay. So now we have properly separated these out. Next step is going to be getting targets from the action script. So that's what's up next. We're going to get targets from the action script. When we do that, then we're going to have the AI be responding. Now, this is going to be a bit difficult to do because I'm thinking for the actions, we need to work on getting that parameters to get these actions. So we need to rework how this goes. So you can see here what we're doing is we're actually getting targets here, and then we're taking those targets and we are triggering those effects on those targets. What we want to do instead of getting targets here, so let's go ahead and instead of getting targets, so what we want to do is instead of doing this here, what we want to do is something like this. So we have action data passed in here, and we want to create a method on action data. So what we'll do is we would keep the targets there. We would do targets equals action data dot get targets, just as simple as that. And then it's going to have its own origin. So we can just pass in, probably want to pass in manager, and then effect. So for each effect base, effect and all action data all effects. So what we need to do is take the radius, no longer do it on the effect, but move the radius from the effect to the action data. So it would actually be passing in. So we would pass in manager and then action data. Actually, we don't even need to pass that in because it's going to be using the origin based off of this to do that calculation. So yeah, we pass in action data, and then this is going to be a static method. So actually it would be like this. Action data dot get targets action data. Yeah, okay. I'm thinking it could just be action data dot get targets, like, but I think I'd rather have it be a static method since it's a calculation that can be performed regardless. So I think it ought to be static. I'm not too sure. I'm still learning when to use static methods and when not to, but I think in this case we'd want to use a static one. Okay, so that's what we're going to be setting up. Instead of getting targets here, we need to get it there, and then we'll do the same thing. See, it's nice being able to just scroll up and the other code is right here instead of going to a different script. Okay, so actually we have this here. So I was actually kind of already starting this. Let's go ahead and do that. Now calculate targets. I imagine this is actually doing nothing right now. So yeah, you could actually just go ahead and use that. Calculate targets, and then we can do this here. So let's just go ahead and override it right now. Targets equals action data dot calculate targets, pass in that action data. So now this is going to be something, some method to grab targets based on. So I guess I already had the right idea when I set this up like 2 months ago. Okay. So I'm going to be starting on that. Yeah. Okay. Okay. I also just changed this real quick. Whoops. Okay. I changed this. It was also doing the same thing where it grabs targets based on the effects radius and then gets it there. So what we're going to do is get rid of that and then put this here where we get targets from the action data. And I think I'm going to take a break. I will probably stream again, even though it's 12 a.m. I'll probably be working super late, I guess super early, whichever you want to think about it. So I will end for now, take a break to eat, and then get back to it. I think I'll stream again just because I don't want to. I'm going to be working regardless, and I don't want to have explained all of this just to not show the rest of it. So I'll probably resume it, but ending for now. Okay, I'm starting again. Just kind of showing the flow again, but when I stepped away, I realized this should be not a static method because by making it static, we're having to pass in the entire struct when really we only need part of the struct's data. So it'd be better to treat it as a method within the struct. That way we're not passing in more data than we need. So did that side change, and I'm going to start working on making calculations based on parameter data here, and then getting targets, and probably visualizing it, trying to visualize it as well. All right, so it took more time than I expected, but you can see what I've got set up here is a way to add spheres to be drawn for kind of debugging this action system. So what I have currently set up here, I will show it and then kind of go back through the code, but we have set up that the moment the mulking enters the forecast state, we look at this action. So forecast action, we have an attack, which will be a melee. We've given it some parameter types. The only ones that matter right now are the shape types. So point can be one particular point or a sphere. So it can expand out from that. And then we will go on to adjusting vertical, horizontal, diagonal, cross. Although I'm thinking these might be overkill and we could just use point and then just change the shape dimensions. But let's see about that. But so we use the shape dimensions to dictate the radius, or I guess center and scale of the sphere. So if we go right now with that 111, you can see it starts right there. Now it doesn't track because we don't have it set up yet to track the position of the hand, but it's doing the effect that we have set up. It's doing it correctly, and then we can see that it's still working if we change the scale to be double. And let's go ahead and run it again. You can see it's scaled double now. And we can go ahead and test doing different dimensions and run it again. And we can see the depth there changing. So let's see if it stays consistent. Depth should be facing towards it. Now it's rotating with the object itself, so that's changing how that's going to work. So we might need to rethink how we're doing this. Let's see what happens if we do breadth. Okay, forgetting for a moment. Okay, so it's going that way. I think what we should do is, right now we're referencing the object, when what we really should be doing is referencing the manager. So we're passing in the surrogate here. So I think what we'd really want to do is do surrogate.transform.rotation, because what we want is the rotation of the root, not the rotation of the current object, because it makes sense for us to use the position of the hand, but it doesn't make sense for us to use the rotation of the hand in terms of drawing this out. So let's do that surrogate instead, and let's see how that goes. So what we're going to do here is test it again and just see if it's actually working better now. Let's go with 4 on that. So depth should be the forward, so it should be longer in the direction that the mulking is facing. Okay, that's true. And let's test. Breadth should be up, down. That doesn't quite make sense. Well, let's see. I might need better naming for that. Just simply call it like horizontal or something. But anyways, yep, okay. And then width is a bit more easy to understand. It's going to be how wide it is. So let's make sure that's true. Okay, and so that's working now. We're grabbing the rotation of the manager itself. Now, okay, so this is great. It's functioning as expected. Obviously, we're not doing any code yet. So I've just set up the debugging, drawing that out. We might want to set up a cube as well. So I might do drawing a cube because what we're trying to do is draw what will be the detection for this. And so it kind of makes more sense to draw a cube for things which are not spherical. So perhaps what we could do perhaps what should happen is that the shape dimensions inform, because I'm trying to think, why do we have these types? The reason for it is to inform the AI how they might want to dodge a certain attack. For example, a vertical dodging left to right would be better. Horizontal jumping up and down or moving up and down would be better. Diagonal, you want to move to one side of it but not the other. And cross, you want to just get out of the way. Same with point. So that's the reason for this. And if the reason for that is to inform the AI, then it might be a better idea to take shape dimensions so that when I'm creating an attack, I give it shape dimensions. And then from there, from the shape dimensions, we figure out what the shape should be. So let's say we did something like this with 1, 4, 1. We could do something where we calculate what's the ratio of this. And we see that and we go, okay, that's going to be horizontal because it is moving like XZ rather than going up. So something like this as well. If it was like, that's moving. Okay. He's out of there. Okay. Like that's obviously horizontal. So I think it's something we should calculate out. Except also across would be rotated, so we'd have to do something where we rotate it. So in that case, I think it has to be a combination thing, because let's say we wanted to cross. Well, now you can't really draw a cross just by passing in shape dimensions. You have to change the rotation of it. So either we could have another value here for offset rotation. And we might need that because if we're doing a cross, then we would need to know, is it left or right cross? So I think we'll need a value for rotation. So we need another value for shape dimensions, getting a rotation in there. Okay. Yeah, there's still a lot to figure out here, but we've got the debug showing for a little bit there, and a little bit more to do with this stuff as well to figure out exactly which we should do. Some of this stuff is just for informing the AI, like this stuff is just informing what this action will do. But this is informing how we will handle targeting. So for example, linked is going to be following along with the object. So the Mole King's melee attack, it needs to be following that hand. Like when we fire this attack, we need to be following that hand as we do the attack, which isn't happening right now. So let's go back to point real quick. Like it's not moving with the hand. So that's what linked would be. Linked would be moving with the hand. Preset would be it just stays where it is. So for example, if this was preset, then this would actually be what we want, doing something like this. Then guided would be we need a target. We need a target to go towards, and it's going towards that. And I can't remember. I wrote it down, but a long time ago, what the logic was here. think it's at the beginning of this. Yeah, okay, here we go. So yeah, vertical, horizontal, diagonal, point can have radius. So really, we could get rid of vertical, horizontal, and diagonal and converge that into one. Because if we're going to have a rotation value for the cross, you could just have it be 0 or 90. Like, why complicate it by having those three things? I mean, we could use that in terms of, well, no, because, okay, I'm trying to think if the AI is looking at this data and it's going to be getting the targets, it can see that it is a target, but it wouldn't exactly know how to avoid that damage. But what it could do is test different actions to see, okay, if I went to this position, would I be out of it? If I went to this position, would I be out of it? Or maybe what we could do, if we treated every shape as a cube rather than a sphere, then we could always specify the most extreme points of that shape. So let's say we had 1, 1, 1, and it's always a cube. And so then we have 1, 4, 1. We could grab actual world positions based on the origin of the attack. And then what we could do is use that to inform which direction, where are we relative to that within that bound. So if you were to picture, let me try drawing this out. Okay, so let's say we've got a cube, which is the hitbox of an attack, right? So we've got this dimensions. It could be a cube, it could be a rectangle, like it could be going out in any directions. The more important part is we have these points here. So let's say we've got our points of contact here, here, here. I'm being way too attentive about the details of this. Okay, so let's say we've got the AI, right? And we've got the AI in this top left corner here. And we know the positions of these points because we know it's a cube. So we could say, which one are we closest to? We're closest to this one. So we want to move in a direction that gets us either up this way or that way. And so from that, we can see which one's closest. Well, okay, so we'd be here and we'd grab, okay, which plane is going to get us out furthest? So we could do a calculation of distance. Let's simplify the AI's movement to be orthogonal. So it can only go any of these directions. And so it says, okay, we know we're in this corner, so we're only going to worry about moving this way, or this way. We know like if we were to divide this into like 3 axes, this is really not easy to draw. Okay, so you imagine 3 axes, it's in this upper quadrant, and it says, okay, so our best options are going to be moving up, moving that way laterally, or moving this way laterally. And then it can say, okay, well, which moves do we have? Then we could also move orthogonally this way. So we could move up with like some jump ability if we have one, or move that way, that way, that way. Okay, so let's calculate out. First thing, the better calculation would be like, is there a wall here? Is there a wall here? Is there a wall here? But let's say which way is going to get us out faster? Let's say it's closer on this side. Okay, this one will get us out faster. This one's the winner. We're going to go that way. I don't know. Maybe that's overcomplicating it. It definitely is. But yeah, I don't know. That's what I'm thinking right now. So that leaves me wondering how we're going to do the shape dimensions, how they should factor in. We can definitely condense vertical, horizontal, diagonal. And then what else was I looking at? I was looking at this. This is the whole reason I took out the notes. Okay. So we have linked preset, which is like static, but you can't use static in a enum, so I called it preset. Then we've got guided, homing, raycast. Now, I don't think I wrote down what the difference is between guided and homing, which I don't know what the difference would be now. We're just going to get rid of this for now because that's not going to be important. Okay. So we've got linked preset, guided homing, guided. Oh, okay. I know what it is. It's guided is move to position. Homing is track target. That's what the difference is. Okay. So this guided would be like we're given a position and we can go towards that position. So it's guided towards a position. Homing is tracking a target. So it can follow a target as it's moving. That's the difference. Okay. Now let's do, we've got cross. I'm trying to think, is there ever a situation where a cross wouldn't just be a point? Because, all right, let's visualize it for a second. There's an attack coming where it's a cross instead of anything else. It's like this. So let's say you've got two swords and you slash at the same time and it like sends out an X like it's anime or something, and you get like this and it's like going forward. Is there any reason we shouldn't just treat that as a sphere? I'd say no. We're going to treat it as a sphere. Okay, so let's get rid of cross, and let's just have line or point. So really that could be cube or sphere, couldn't it? Shape type could be cube or sphere. Because if we think about it, if a line isn't literally a line and it's more dimensional, so like horizontal, vertical, whatever. Okay, so if we've got horizontal here, like a horizontal attack, it's not literally going to be a line attack. It's going to have dimensions that are like this. Like this, and then it's going to be three-dimensional as well, even if it's very slimly three-dimensional. So it'd be like that. It's a cube, because we don't want that to be a sphere. We don't want that to be some stretched sphere. So then the next thing we'd have is an actual sphere where we're doing a whole point rather than a cube. Okay, so I think that's really all we should differentiate is it a cube or is it a sphere? Now, what I'm thinking about is how we can get targets in a oval. Because I don't know how to do that. Okay, let me just document this stuff and then I can think about that stuff more. Okay. Okay, and then we want to add one thing here. Well, first of all, let's organize these in the way that they should be, because if front back is going to be the Z, up down is going to be the Y, width is going to be the X. So let's change it to be reflective of that. I'm thinking the rotation doesn't need to be anything more than an S-byte, because if you're rotating something but it's always about the same origin and it goes across in the same length, like you could think of it as a radius in terms of it's going across, its midpoint is always the same. So if you rotate it one way, you might as well rotate it the other way. So you shouldn't have to go more than 90 when it's rotating. Okay, so we can track that there. Got rotation. All right, I think I'll stop commenting on this stuff because I'm not really sure what to do. So it'd be better if I just work on it and then comment it once I figure it out. Okay, I'll explain briefly what I've set up, and hopefully actually briefly this time, because there's still more to do, but I've set up the two different shape types. So we have cube and sphere. So cube, we can set this up with a width of 4, which is going to be left to right. We can think of this as X, Y, Z. We should throw tooltips on these. So let's go, I guess, I don't think we can get tooltip. Okay. No worries on it. Actually, no, we can. Okay. Action data, let's go here, and now let's go to this. If we've got it as okay, if we do that, and then we take okay, so now we got tooltips there. All right, so we go width, breadth, depth. And if we do this and we go restart it, so we can change the rotation of it as well. Let's go with the cube and width of 4. We can do this and see it's got the width there. And then we can also change the depth to like 0.1. And I don't think that's actually, oh, well, yeah, we can't do down to 0.1. Okay, so we actually might want to multiply. Oh, that's something for another time. Let's do 1. We can change this to 2 as well. And you get it. It changes. And then we can do rotation as well. We can change this to 45, and it'll rotate about the forward direction of the mulking. So you can throw this to idle, and it rotates 45 that way. It might be a bit more obvious if we do that. And then change this to like 6. And we can go negative 45. And we'll go in the opposite direction. So we can see there. Now you can see kind of how that lines up with the sweep attack. So there could be a case where we might want to do it in one instance rather than over time, or even if we did it over time, we could still use this general shape. So we could do something where we use the general shape and then forecast and like kind of do it 1, 2, 3, 4, like 4 checks or something, and do that over time. And so now we can customize that. We can change this back to a sphere. Rotation won't do anything with a sphere because, I mean, it doesn't matter. Well, it does matter, but I don't want it to matter for a sphere. I'd rather just keep it simple. So we can see that there. And then we can do this. Change that, and it will still function the same. We can do something larger. So yeah, that's working out well. We're able to draw it. Now I'm going to be setting up different targeting types and figuring out how exactly I want to calculate overtime effects, because the preset is the easiest because it'll occur once.